In this video, we are going to be talking about sample space and how to identify that sample space of given events. So first off, sample space is the set of all possible outcomes in a probability event. So if it's just flipping one coin, you could do heads and tails, that is the sample space. However, if you're flipping two coins, it'd be like heads heads or heads tails or tails tails. And we're going to display this using a tree diagram because it keeps it nice and neat and makes sure you get all the possible events. So when you're making a tree diagram, you're going to start by listing your first outcome option with space between them. It's really important that you give yourself some space because you're going to be branching off and you need that room. So you're going to make the branches, which is why it's called a tree diagram, for each of the next outcomes off the first listing. And then keep going until you have made the branches for each type of outcome. So here's our first example. A vendor sells vanilla and chocolate ice cream. Customers can choose from a waffle or sugar cone. Find the sample space for all possible orders on one scoop of ice cream in a cone. Okay, so they can choose the ice cream, or they can choose the cone. So they're either going to choose vanilla, or they're going to choose chocolate. So we listed our first outcome. If they're choosing the ice cream, they can say, I'd like vanilla or I'd like chocolate. And then they get to choose what kind of cone. So if they choose vanilla ice cream, they can either choose a waffle cone, or they can choose a sugar cone. Okay, let's say they wanted chocolate instead. They are still allowed to get a waffle cone, or they can get a sugar cone. So we have four possibilities here. We have vanilla waffle, which is this first line. We have vanilla sugar, which is the second line. We have chocolate waffle, and we have chocolate sugar. So we have, if we list it off, you can get vanilla and waffle. You can get vanilla, for sake of space, I'm just going to abbreviate, vanilla or sugar, or with sugar cone. You can get a chocolate and waffle cone, or you can get chocolate ice cream with a sugar cone. So these are your four possibilities. So this is your sample space. What we did over here, this spot, this is called the tree diagram. Okay, so you can see the lines, that's considered your branches. All right, Peter and Linda are playing a game in which the spinner is spun twice. Okay, so a spin one, and then spin two. Go ahead and list those. If the sum of the numbers is even, Peter wins. If the sum of the numbers is odd, then Linda wins. We want to make a tree diagram to show the sample space, then find the probability that Linda wins. So they spin it once, and here's our spinner up here. They can get a 1, 2, or 3 on the first spin. So let's say they spin a 1 on the first time. They're still allowed to get a 1, 2, or 3 on the second spin. If they spin a 2 on the first one, they can still get a 1, 2, or 3. And if they spin a 3 the first time, they can still get a 1, 2, or 3 on the second spin. You can see how crowded this gets on the second option very quickly. That's why it's important that you give yourself space on that first option of 1, 2, and 3 right here. All right, so our outcomes are 1 and 1, 1 and 2, 1 and 3, 2 and 1, 2 and 2, 2 and 3. Okay, to get these, I'm just reading from here. So 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. And then I can get 3, 1, 3, 2, or 3, 3. Okay, using this last one, 3, 1, 3, 2, 3, 3. So these are all the outcomes. So now it says if the sum of the numbers is even, then Peter wins. If the sum of the numbers is odd, then Linda wins. And we want to know how many times Linda won. That's our final goal. Okay, so we want odd sums. Sum, remember, means adding. So 1 plus 1 is 2, so this means that Peter won. 1 plus 2 is 3, so that means Linda won. 1 plus 3 is 4, so Peter won. 2 plus 1 is 3, so that means Linda won. 2 plus 2 is 4, so Peter won. 2 plus 3 is 5, so Linda won. 3 plus 1 is 4, so Peter won. 3 plus 2 is 5, so Linda won. And then 3 plus 3 is 6, so Peter won. So there are, if we count them up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. That's going to be our denominator because it's the total number of outcomes. And Linda won 1, 2, 3, 4 of those. So she won 4 out of the 9 times. So you can see this game is kind of rigged. Peter is going to win more often since he wins 5 out of the 9 times, and Linda is only winning 4 out of the 9 times. Alright, so here's your practice. So pause the video and try this. We have a sandwich shop, or at a sandwich shop, a customer can choose between white and wheat bread, between turkey and ham, and between American Swiss or no cheese. List every possibility of sandwich a customer can order. So I want you to make a tree diagram on this. And if I go back to this other one real quick, this was only 1 and 2 categories, but you're going to have a third one over here of your white bread. Your bread is 1, your type of meat is the second option, and then your type of cheese is your third. So pause the video now and try this on your own. Alright, so what your tree diagram should look like is this. So you chose bread first, so you were either able to choose white or wheat bread. And then if you chose white bread, you could have chose turkey or ham. And if you chose turkey, you could put American Swiss or no cheese on it. Okay? If you chose white and ham, you still have the option of American Swiss and no cheese. So you can see it. Look how these repeat in clusters of 3, because there's 3 options in this category, right? So this repeats 3 times. This is repeating twice right here, because there were 2 options. And then we have, right here, we're only writing white and wheat once, since that was our first option. Okay? So this category should be a repeat for each of the options. So because you chose white, you can choose turkey or ham. Because you chose wheat, you can choose turkey or ham. And then your cheese repeats no matter which one that you are choosing. Alright, that's the end of the video, so thanks for watching.